Hey guys, welcome back. This is Unit 5 Handout 4, and it's this question number 7 here, which is a weird question about motor with a horsepower and some efficiency, etc. Kind of annoying. Usually I have to take this one up with my students, so I'm going to take it up with you guys as well. Let's talk about it for a second here. It says 120 volt AC motor has 5 horsepower at the shaft. Okay, so here's my picture of my motor. There's the shaft. The nameplate value on the motor is always going to be, the horsepower output or the horsepower at the shaft, mechanical horsepower. But it's running at an 80% efficiency, and then the power factor is 70%, and it wants us to calculate the motor current. And this is a little reminder from level 1. There are always 746 watts per horsepower. Okay, that's something you learned in level 1. So in order to figure out what's going on with this circuit, it's great to know the output power of the machine, but really what we want to know is, this is mechanical power out. Really what we're interested in is how much electrical power is going into this machine, because that's what we're going to need for our power phasor diagram that we're going to try to draw. Okay. Now, if this thing has 5 horsepower at the shaft, and there are 746 horsepower, watts per horsepower, then I can multiply those two together to figure out how many watts are going on at the shaft here. So I'm going to do that. 5 times 746. And this is going to be 3730 watts. And that's going to be the output power in watts. Okay? But we don't care about mechanical output power in watts. What we care about is the input power. Now, in level 1, you guys learned a formula about efficiency, and it was the efficiency, really the formula was efficiency is useful power obtained divided by total power used. If you have a furnace that's 95% efficient, it's because, 95% of the power that goes into that machine is actually being used to heat your house. The rest is going out the chimney. So really the shortened form of that formula is it's the power output divided by the power input. Okay, that's going to determine the efficiency of the machine. Times 100 if you want to put it in percent. Now we know the output power and we know the efficiency. What we're after is the input power, and we can transpose this formula. It's going to be the power out divided by the efficiency. And my power out is 3730, and my efficiency is 80%, or 0.8. And now this will actually calculate the electrical power going into this machine in order to produce this 5 horsepower at the output. Okay, so if I go 3730 and then divide it by 0.8, I will get 4663 watts. And that is going to be, the power, electrical power input into this machine. Now, a couple things about this, guys. You must divide here, because I've seen a lot of students when they're doing these, they take this 3730 and they multiply it by 0.8, and they think that might be the input power. But if you multiply 3730 times 0.8, you'll get a number that's less than 3730. And there's no machine on the planet, guys, that outputs more power than goes in. Okay, that does not exist. 20% of the energy that's going into this machine is being wasted as heat. Okay, it's being lost in the machine, and you're only getting 80% out. Okay, and so this is 80% of the total power, which is why if I divide by 0.8, I'll get a bigger number. You want to make sure your input power is bigger than your output power when you're doing this question and questions like this. Okay, guys? So that's the first, battle. The second battle is we're going to have to draw a power phasor diagram, because the only way to calculate the motor current is to know the VA, all right? Because VA is E total times I total. We know the total voltage, and we're trying to figure out the total current. And so my power phasor diagram is going to look like this. And the only question is this 4663, let's see, power factor is 0.7, guys? Okay, so the only other question is this 4663, is it the VA or is it the true power? What do you guys think? Well, there's a couple of hints that you can use to determine it. The first thing is that it's measured in watts, and anything that's measured in watts is true power. But also, You know, true power is power that does work, guys. And this motor, this 3730, is work. It's mechanical work, okay? It's 5 horsepower. That's how much work this thing can do. Even the 20% that you're losing is work because it's being lost as heat, okay, guys? So it is the true power. It's measured in watts. That's your first hint. It's actually horsepower, which is your second hint, okay? And heat, that it is all power that does work. Now that I do know that, I can calculate my VA. My VA is going to be my power divided by my power factor, guys. And so it is 4,663 divided by 0.7. And, you know, the reason that's true is because the VA formula, or sorry, the power factor formula is P over VA. And if you transpose that, then the VA is equal to the P divided by the power factor. And not only that, but if you accidentally multiplied this, you would get a number that's less than 4663, okay? And then there's no way the VA is less than this, all right? So we're going to divide, make sure we get a nice big number there. 4663 divided by 0.7 looks like it is 6661 volt amps. Now we could calculate the VARs. You know, we don't need to though, but we could, right? Be Pythagorean theorem, we could easily calculate it. But really the question is only asking about motor current. And since VA is equal to E total times I total, you know, then I total is equal to VA over E total. And so it is 6661 divided by 120. And this thing draws a ridiculous amount of current, 55 amps. Okay, guys? All that work, all right, to calculate the motor current. All right, guys? So give the rest of your homework a try. Make sure it's working for you. Let me know if you have any questions about it. You can email me, send me a message, whatever works. You know, I'll get back to you. Ask some of the other students if I've been getting back to them or not. You know, I get back to all my students, so don't be shy. Ask a question if you have a question. And if you want, you know, if I get a bunch of requests for another one to take up, I'll do that as well. In the meantime, have a good day. Enjoy the sunshine, and you know, be good to each other, and see you soon.